Hi everyone, let's solve a question called coin change. So in this question, we're given integer coins representing coins of different values, and then we have integer amount representing total amount of money. So here we want to find the smallest number of coins that we need to make it up to the amount. Let's check example 1 to see what the question means. So example 1, the coin is equal to 1, 2, 5, right? And the amount is 11. So if we pick 2, 5, and 1, 1, we sum it together, we get 11, which is smallest approach we need, so we return 3. And example 2 here, coin is 2, but amount is 3, so there's no way we can reach the target, so return -1. And example 3 here, coin is 1, but amount is 0, so we actually don't need any coin to reach this amount, so we only need to return 0. Okay. Now finish the quick problem introduction. The next thing to think about how to solve this problem. So this problem, we are using the dynamic programming approach. And for dynamic programming approach, the fundamental thing is to write out the transaction formula, which I show here. So let me use the graph drawing here, our example 1 to show you how it works. So you see example 1 with coins, okay, these coins equal to 1 to 5, right? And then we have the amount equal to 11. Okay, the amount equal to 11. And now, before running the dynamic programming search, we have to initialize the DP, right? So in this DP, we want to use the money value to search the numbers of operations we need to reach the amount. So let's say it's count. Okay, now finish the initialization DP. Let's keep searching the DP using this amount. For DP 11, we have 3 approaches. If that the current coins at this stage, then we'll use up a 1 operation at this stage, right? So I'll add 1 here, and the remaining money will change from 11 to 11 minus 1, right? So this one will be 10. And if we select the current coins at 2, then again we use our 1 operation, so 1 plus, and the remaining will be 11 minus 2, so it will be 9. And if we select current point at 5, we get 1 plus DP and 6. Okay, so see in this equation find the minimum numbers coin operation, right? And this 2 is obviously greater than this one. So we just skip in these 2 and just find this one. And for this DP6, well, 1 is go through 1 plus DP5 if select 1 in the current point. And 1 to go through 1 plus DP4 if we select 2 at the current point. And the final approach is 1 plus DP1, right? And you see this 2 is obviously greater than this 2, so just skip this 2 approach and only need to check this one. And you see DP1 is very simple since we have 1 here, we only need 1, 1 to reach a 1, right? So DP1 equal to 1. So this means DP6, which is 1 plus DP1, is 1 plus 1 equal to 2. So this is 2. And DP11 here is 1 plus 2, right? So it will be 3. And the final thing we want to return is this 3. That's our result. Okay, now finish the graphical abstraction. Let's start into the coding part. So first, we need to initialize dynamic program array. Since here, if we meet amount equal to 0, then we don't need the coin. So DP0 is set to 0, right? And then we need another, let's say, float infinity values with the length of month. This means, okay, anytime we update, the DP value will go from the larger values to smaller value, right? Okay, now finish the initialization of DP array. Let's go through all numbers from a month, from 1 to a month, and then go through all the coins. If I is greater or equal to coin, it means still makes sense to keep searching the next iteration. If that case, we want to run the dynamic programming approach. So that copy paste here, and you see DPI equal to minimum between the previous set DPI and the current dpi minus c plus 1. This means, okay, this one is the current operation we use for this coin, and this I minus coin is the remaining value after deducting the value of the coin. Okay, and finally, we have to consider if we have make some update in this for loop. This means we can finish this operation, right? So if dp, the last element, is not float infinity, this means we can finish. So we simply return dp minus 1 as the smallest numbers operation we need. And otherwise, if dp minus 1 is still float infinity, this means we have not go through this step to update, right? So this means we cannot finish, so we just return minus 1. Okay, now finish the coding part. Let's submit the result to see it works. Okay, you see the time capacity memory usage of this solution is not bad, right? And I think the code is very short and easy to understand. If you like this video, please subscribe to my channel, and I'll see you next time. Thank you.